It begins not with a roar, but with a silent, impossible blush of color. In a fishing village on the coast of Thailand, a child points a trembling finger. He points towards a sky that should be black, a sky pricked only by familiar stars. Tonight, however, the heavens are alive with a spectacle his ancestors never recorded. Great curtains of emerald and rose impossibly vast shimmer above the Andaman Sea. They dance with an ethereal grace, a silent symphony played on an unfamiliar celestial stage. Simultaneously, in the heart of the Amazon rainforest, nocturnal creatures fall silent. Tribes who have navigated by the stars for millennia gaze upward in bewilderment. The canopy, usually a thick blanket of darkness, is illuminated by an otherworldly glow. Ribbons of violet and crimson light pulse and sway, painting the ancient trees in phantom hues. This is a magic for which their oral histories have no name, a divine and terrifying visitation. Across the globe, the phenomenon repeats itself with breathtaking impartiality. From the sun-drenched plains of Kenya to the bustling streets of Singapore, from the arid deserts of northern Chile to the volcanic islands of Indonesia, humanity united in its confusion steps outside to witness the unbelievable. The Aurora Borealis and Aurora Australis, the celestial ghosts of the frozen poles, have descended into the tropics, shattering our understanding of the world. This is not a gentle miracle, it is a warning. What we are witnessing is the beautiful, terrifying evidence of a planetary assault. It is the visible aftermath of an invisible cataclysm that began 93 million miles away. The year is 2025, and the most powerful solar storm in recorded history has just made landfall on Earth. Our technological civilization, a delicate and intricate web of our own making, is now under siege, and we are only just beginning to comprehend the scale of the silent chaos unfolding around us. To understand this celestial invasion, we must journey to its source. We must travel to the heart of our solar system, to the seething, violent furnace that gives us life. Our star, the Sun, is not the benign, constant orb of our daily experience. It is a perpetual thermonuclear explosion, a churning sphere of plasma, roiling with unimaginable energies. Its surface is a tempestuous ocean of fire, where magnetic forces 1,000,000 times stronger than Earth's wrestle in a constant titanic struggle for dominance. For years, solar physicists had watched Solar Cycle 25 with a mixture of professional curiosity and growing unease. Solar cycles are the star's natural rhythm, an 11-year ebb and flow of magnetic activity. During the solar minimum, the Sun is placid, its face a nearly unblemished canvas of gold. But as the cycle progresses towards its maximum, its disposition darkens. Vast cool blotches appear on its surface, blemishes we call sunspots. These are not mere discolorations, they are immense magnetic anomalies. Each one is a region where the star's internal magnetic fields have become twisted and contorted. They breach the photosphere like colossal, deep-rooted wounds, some large enough to swallow our planet whole. Imagine a series of immense planetary-scale rubber bands anchored deep within the Sun's interior. For months, even years, these magnetic field lines are stretched and twisted by the star's differential rotation. The Sun's equator spins faster than its poles, a motion that continually winds these invisible elastic bands tighter and tighter. Energy accumulates, building to a state of almost unbearable tension. The sunspots we observe are the visible anchors of this immense stored power. They are the focal points of a stellar engine loading its cannon for a cosmic barrage. For weeks leading up to the 2025 event, a particularly monstrous complex of sunspots designated Active Region 3857 had been rotating into view facing Earth directly. It was a sprawling archipelago of magnetic chaos crackling with solar flares, the opening salvos of a much larger war. Then the rubber bands snapped. In an instant of cosmic violence, a century's worth of stored magnetic energy was unleashed. This was not merely a solar flare, a brilliant flash of radiation that would reach us in 8 minutes. This was a far more formidable beast, a coronal mass ejection, or CME, a titanic bubble of magnetized plasma. Billions of tons of the sun's own substance was violently expelled from its atmosphere, erupting into the void of interplanetary space. It was a stellar hurricane, a cohesive cloud of protons and electrons bound together by its own tangled magnetic field, hurtling outwards at over 3,000 kilometers per second. A cosmic shotgun blast aimed squarely at the third planet in its path. Our telescopes, our vigilant sentinels in space, saw it happen. The Solar Dynamics Observatory captured the breathtaking, terrifying footage. A great filament of plasma suspended for days above the active region suddenly destabilized. It rose twisted and then erupted in a bloom of incandescent fury. The subsequent CME appeared on the coronagraphs as a vast, expanding halo of light, a ghostly wave of matter obscuring the stars behind it. This was the so-called halo CME, the telltale sign that the eruption was directed straight at us. The models were run, the calculations made, the prognosis was dire. This was not just a powerful storm, it was a Carrington-class event, or perhaps something even worse. A spectre from the 19th century had returned to haunt our hyper-connected 21st century world. The ejected cloud of solar material began its lonely 3-day journey across the solar system. It was a phantom menace, utterly invisible to the naked eye. As it traveled, it plowed through the ever-present but far gentler solar wind, creating a shock wave at its leading edge, like the bow wave of a battleship. This shock wave accelerated particles to nearly the speed of light, an advance guard of high-energy radiation. For the scientists at NOAA's Space Weather Prediction Center, it was a race against the clock. Alerts were issued, emergency bulletins sent to power grid operators, satellite companies, and airlines. But an alert is not a defense. It is merely the tolling of a bell announcing the impending arrival of the deluge. The world held its collective breath, waiting for a collision with an entity it could neither see nor truly comprehend. To grasp what happened next, we must visualize our planet's first and most crucial line of defense. Earth is not a naked sphere in the cosmic firing line. Our world possesses a magnificent invisible shield generated by the churning molten iron in its core. This is the magnetosphere, a vast teardrop-shaped bubble of magnetic influence extending tens of thousands of miles into space. It is a silent, elegant bulwark against the constant onslaught of the solar wind. Under normal conditions, it deflects the stream of charged particles around our planet, channeling a small fraction of them towards the poles where they ignite the familiar auroras. Think of the magnetosphere as a deeply rooted ancient tree in the middle of a constantly flowing river. The river is the solar wind, always pushing, always exerting pressure. The tree's powerful root system is the Earth's magnetic field holding it firm. The branches and leaves are the outer magnetic field lines, which bend and sway in the current. The water of the river is deflected around the trunk, creating a wake behind it. Most of the time, the river flows steadily and the tree stands strong, its structure barely perturbed. But the CME of 2025 was not the gentle flow of the river. It was a flash flood, a tsunami of unimaginable scale and force. When the leading edge of the coronal mass ejection arrived, it struck our planetary shield with brutal force. The initial impact compressed the magnetosphere on the sun-facing side dramatically. The boundary of our magnetic influence, normally 6,000 kilometers away, was pushed inward past the orbit of our geostationary satellites. Satellites responsible for global communications and weather forecasting were suddenly outside their protective cocoon, exposed to the full, unmitigated fury of the solar plasma. The tree was not just swaying in the current anymore, it was being battered by a wall of water. What followed was a complex and violent process known as magnetic reconnection. The CME carried with it its own powerful magnetic field, a remnant of its solar origins. Crucially, on this day, the polarity of this incoming field was oriented directly opposite to Earth's own field. It was a key fitting into a lock. As the two fields pressed against each other, they didn't just repel. They merged, they snapped, and they reconnected in a new and explosive configuration. Imagine two opposing magnetic domains as countless threads of energy. When they touched, they annihilated each other in a flash, releasing a torrent of power. This process opened a direct channel, a gaping wound in our planet's shield. Through this breach, a deluge of high-energy particles and plasma poured directly into our upper atmosphere. The floodgates of the cosmos had been thrown wide open. This is the genesis of the spectacle seen in the tropics. The sheer quantity of energy being injected into the system was so immense that the auroral ovals, the rings of light that normally shimmer over the Arctic and Antarctic circles, expanded catastrophically. They swelled outwards from the poles, spreading down across Canada, Europe and Asia, in the north and up from Antarctica to cover Australia, southern Africa and South America. And still the energy kept coming. The system became so supercharged that the Aurora spilled over its traditional boundaries, flowing like luminous rivers down to the equator itself. The fishermen in Thailand were not witnessing a polar phenomenon. They were witnessing the sign of a planet's magnetic defenses being utterly and completely overwhelmed. While humanity gazed at the sky in wonder, a far more insidious and dangerous process was beginning on the ground. The violent, rapid fluctuations in Earth's magnetic field were inducing powerful electrical currents in the planet's crust. These are called geomagnetically induced currents, or GICs, and they are the nemesis of any long metallic conductor. Our modern world is built upon a skeleton of such conductors, high-voltage power lines stretching for thousands of miles, pipelines for oil and gas that cross entire continents, the intricate web of undersea fiber optic cables that form the backbone of the internet. For power grids, the effect is catastrophic. The GICs flow up from the ground into the transmission lines, seeking the path of least resistance. They surge into the massive transformers at electrical substations, the critical hearts of the grid. These transformers are designed to handle alternating current, the AC power that flows back and forth 60 times a second. The geomagnetically induced current is a direct current, a DC offset. It is like trying to force water through a pump designed only for air. The magnetic cores of the transformers become saturated, they begin to overheat violently. Protective relays designed to prevent overloads are tripped, plunging entire regions into darkness. But in the face of such a colossal GIC, many transformers don't just shut down. They melt, they explode. The Great Blackout of 2025 began in the high-latitude regions where the effects were strongest. Quebec, Scandinavia and Siberia were the first to fall silent. But the storm's unprecedented power pushed the danger zone much farther south. Grids in northern Germany, Poland and the upper Midwest of the United States began to fail. The cascading effect took hold. As one part of the interconnected grid collapses, it places an impossible strain on its neighbors. Like a row of dominoes, one failure triggers the next, leading to a continent-wide shutdown. Within hours of the aurora appearing over the equator, the lights began to go out across much of the northern hemisphere. The silent, beautiful display in the heavens was answered by a creeping terrestrial darkness below. Our history is littered with warnings, omens we chose to interpret as curiosities rather than dire predictions. In ancient times, inexplicable blood-red auroras seen over Rome or Babylon were taken as portents of war and disaster. Chinese imperial astronomers meticulously recorded these celestial dragons, never fully grasping what they represented. They were seeing the echoes of past solar tempests, storms that struck a world without technology, a world where the only consequence was a terrifyingly beautiful light show and a sense of profound dread. But the Industrial Revolution changed everything. We began to wrap our world in a web of wires. The benchmark for all modern solar storms occurred on the 1st of September, 1859. On that morning, a British amateur astronomer named Richard Carrington was sketching a large group of sunspots. Suddenly, he witnessed two brilliant patches of white light erupt from the sunspot group. He had become the first human to directly observe a solar flare. He knew instantly that he had seen something remarkable, but he could not have imagined the consequences. Just over 17 hours later, the associated CME, traveling at incredible speed, slammed into Earth. The Carrington event struck a world lit by gaslight and powered by steam. Its most advanced technology was the electrical telegraph, and that technology was torn apart. Telegraph systems across Europe and North America went haywire. Operators received electric shocks from their equipment. Sparks flew from the telegraph pylons, setting fire to nearby grass. The induced currents in the wires were so powerful that some operators disconnected their batteries and found they could continue to send and receive messages powered only by the aurora itself. That night, the northern lights were seen as far south as Cuba and Hawaii. People in the Rocky Mountains awoke in the middle of the night, thinking it was dawn. The sky was so bright. It was a spectacular, frightening anomaly. But in 1859, it was not a civilization-ending event. If the Carrington event were to happen today, the consequences would be almost unimaginable. Our reliance on electricity and electronics has become an existential vulnerability. We had a dress rehearsal for this disaster in March of 1989. A severe but far less powerful solar storm struck the Earth. It collapsed the entire power grid of Quebec in less than 90 seconds. 6 million people were plunged into a freezing blackout that lasted for over 9 hours. That event was a wake-up call, a demonstration of our grid's fragility. Then in July of 2012, we dodged a cosmic bullet. A CME of true Carrington-class intensity erupted from the Sunday. It tore through the part of Earth's orbit our planet had occupied just 1 week earlier. Had the eruption occurred 9 days sooner, we would have suffered a direct hit. Studies have estimated that the recovery from such a storm would have taken 4 to 10 years, and the economic cost would have been measured in the trillions of dollars. We were given a warning. We were shown our weakness. The storm of 2025 is the consequence of not fully heeding that alarm. As the terrestrial grids falter, a second parallel crisis is unfolding in orbit. The fleet of over 7,000 active satellites that encircle our globe are in grave peril. The initial wave of high-energy protons, the storm's advance guard, can disrupt and damage sensitive electronics. These particles can flip bits in a satellite's memory, causing software glitches or phantom commands. In more extreme cases, they can cause a total electrical burnout, creating a permanent piece of space junk. Our GPS constellation, the system that underpins everything from global shipping to financial transactions to simple navigation, is particularly vulnerable. As the main body of the CME envelops the planet, a new threat emerges: atmospheric drag. the immense energy dumped into the upper atmosphere causes it to heat up and expand dramatically. The tenuous outer layers of our air swell outwards, reaching into the altitudes of low Earth orbit satellites. For these objects, traveling at 17,000 miles per hour, plowing into this newly thickened atmosphere is like hitting a wall of molasses. Their orbits begin to decay rapidly. Without immediate and repeated course corrections from ground control, they will spiral downwards and burn up. But with the ground grids failing and communications disrupted, who is left to command them? The sky, our vital high ground for observation and communication, is becoming a graveyard. And then there is the internet. The global network we perceive as a wireless cloud-based entity is in reality a physical thing. It is a planet-spanning network of data centers connected by immense fiber optic cables. The most critical of these cables lie on the ocean floor, stretching for thousands of miles between continents. These cables require powered repeaters every 50 to 80 kilometers to boost the signal, and these repeaters are powered by electrical conductors that run the length of the cable. They are in effect 1,000-mile-long wires perfectly designed to pick up geomagnetically induced currents. The same force that melts transformers on land can now overload and destroy the repeaters that form the arteries of our digital world. A single powerful storm has the potential to sever continents, to fragment the global internet into a series of isolated national or regional networks. The World Wide Web, the greatest engine of connection in human history, could be broken. The magnificent lights that now dance over the equator are a sublime distraction from the grim reality. They are the result of the fundamental physics of atoms and energy. When the high-energy particles from the sun, guided by the distorted magnetic field lines, rain down into our atmosphere, they collide with atoms of oxygen and nitrogen. Each collision is a miniature fleeting transfer of energy. The atmospheric atom absorbs the energy from the solar particle, kicking one of its own electrons into a higher unstable orbit. The atom is now in an excited state. But this state cannot last. Within a fraction of a second, the electron falls back to its original stable energy level. As it falls, it must shed the excess energy it absorbed. It does so by emitting a single discrete particle of light, a photon. The color of that photon, the hue of the aurora, is a fingerprint of the atom that was struck. High in the atmosphere, above 200 kilometers, collisions with oxygen atoms produce a haunting, rare blood-red light. At the more common altitudes of 100 to 200 kilometers, it is oxygen again that dominates the display, but here it emits the brilliant iconic green-yellow that is the aurora's signature color. Lower still, below 100 kilometers, nitrogen atoms take over the performance. When they are struck, they paint the sky in shimmering blues and deep purples, often forming the sharp, moving lower edge of the great auroral curtains. The celestial draperies seen over Thailand are a complex masterpiece painted with atomic precision, a canvas of atmospheric gas struck by a brush of solar plasma, creating a transient, silent, and overwhelmingly beautiful testament to a planetary violation. What becomes of our world in the days and weeks after the great storm of 2025? The immediate aftermath is one of confusion and isolation. Without power, without GPS, without global communications, our intricate systems of logistics begin to fail. Supply chains for food, water, and medicine are disrupted. Financial markets, which depend on nanosecond timing and global connectivity, are frozen. We are cast back into a pre-digital, even pre-electrical age, but with a population of 8 billion people who have no memory of how to live in such a world. The recovery will be slow and arduous. The most critical damage is to the high-voltage transformers. These are not off-the-shelf components. They are gargantuan custom-built machines that take months or even years to construct, and we have very few spares. With manufacturing and transport systems crippled, replacing the hundreds of damaged transformers becomes a monumental task. It is a recovery measured not in days or weeks, but in years and perhaps even a decade. Humanity will have to learn to live on a fractured planet with islands of power and light, surrounded by vast regions of darkness and silence. This event forces upon us a profound and humbling philosophical reckoning. We have built a civilization of exquisite complexity, a technological Tower of Babel. We have convinced ourselves of our mastery over nature, and yet a single predictable tantrum from our parent star can bring it all to its knees. We are not masters of our environment. We are subjects of it. Our existence is entirely contingent on the relatively stable mood of a middle-aged star. The same celestial body that nurtures life with its warmth and light holds the power to extinguish our way of life with a single indifferent exhalation of its atmosphere. Looking forward, we must ask ourselves if this was the big one. The geological and astronomical records suggest it was not. Studies of ice cores have revealed evidence of past solar events preserved in layers of nitrates that dwarf even the Carrington storm, and astronomers observing other sun-like stars have witnessed superflares, eruptions of energy thousands of times greater than anything our sun has produced in recorded history. There is no physical law that prevents our own sun from doing the same. The storm of 2025 may not be the ultimate test, but rather the final desperate warning shot. The path forward requires a new kind of planetary resilience. It means hardening our electrical grids, developing transformers that can withstand DC currents. It demands a more robust and redundant satellite architecture. It necessitates the creation of sophisticated AI-driven space weather forecasting systems that can give us not just days but perhaps weeks of warning. It is a challenge on the scale of global climate change, another invisible threat that requires unified global action. We must invest in our shield, both the natural one that envelops our world and the technological one we must build to protect our creations. As the days turn into weeks, the great auroras of 2025 finally begin to fade from the tropical skies. The last ghostly tendrils of green and violet retreat back towards their polar homes. The sky over the Amazon returns to its familiar star-dusted blackness. The impossible light show is over, but it has left an indelible mark on the human psyche. We have been made aware in the most spectacular fashion imaginable of our true place in the cosmos. We are inhabitants of a tiny, fragile world, adrift in a sea of cosmic radiation, utterly dependent on the delicate balance of invisible forces. The storm was a catastrophe, but it was also a revelation. It was a terrifying, beautiful, and necessary reminder that we are children of the stars, forever subject to the whims and the power of the universe that gave us birth. The lights are gone, but the lesson and the darkness remain.